Hi guys, it's still Mr. Richard. Hope you're well, guys. In this video, I will be working with question 7. Yes, I will review all the questions per video so that we get to understand how we can answer the final exam questions, right? So today I prefer that let me work with question 7. The other video we are going to work with question 2 and the other questions, right? So if you are new to this channel, what are you waiting for? Let's do this. 1, 2, 3. Let's subscribe. Oh, thank you guys. Let's grow the community. Let's grow this community so that we have more content, and we will develop our content step by step, right? So we are at question 7, at 7.1. Yes, forgive me for my question paper. It's kind of messy. I got this from a student, but I decided that let me work through this question paper so that you guys can benefit and learn, right? So we are at 7.1. Determine f of x from prime f of x from first principle if x squared plus is equals to, if f of x is equals to x squared plus x, right? So what is happening here? They want us to find the first derivative from first principle. So we are given x squared plus x, right? So let's put this into practice without wasting time. So we are at question 7, right? Question 7, 7.1. We are given f of x is equals to x squared plus x. That was 5 marks. This is from November 2022, paper 1. Yes, it's a national paper in South Africa. Right. So first thing first, when they want you to derive this in first principle, I advise that first check what will be the answer, the possible answer there. So using the differentiation, we will say f of prime there. Therefore, using a power rule, we know 1 times 2, that will be 2. Then 2 minus 1, that will be left with x, right? Then we have 1 here as a coefficient and a power. Using a power rule, 1 times 1 will be definitely it will be 1. 1 times x, it's x, and 1 minus 1, it's going to be 0. X to the power 0, that will be 1. So in other case, your answer should be, you should get 2x plus 1. So, but let's put this in a first principle. F prime, f of x plus h subtracted by the given function divided by h. Let me not forget, as limit approaches 0, right? Okay, limit as h approaches 0. Sorry for that. Where there is x, we shall replace it by remember that we are given as x squared plus x, right? Where there is x, we shall replace by x plus h. Yes, you replace it by x plus h. So we are going to have x plus h squared plus x plus h subtracted by the given function, which is x squared plus x, right? Divided by h. Don't forget, this is limit as h approaches 0. So we are going to work this using algebraic method. First thing first, you're going to square x there. When you square x, you're going to have x squared. Then the power will multiply everything that is inside the bracket. 2 times h times x, we are going to have 2hx, right? Then we square the last, that will be h squared. Then we take out this from the bracket, so it will be x plus h. Then remember that the negative affects everything that is inside the bracket. So in this case, we are going to have negative x squared minus x. Okay. All right. Divided by h. Okay. So from here, we are going to have limit as h approaches 0. So from here, you check your like terms then. Do we have x squared and x squared? It's 0. So they will cancel each other. Then we have x and x, which is also be 0. They will cancel each other. Then we are left with 2xh plus h squared plus h. Okay. All right. Okay. It's fine. So divided by h. So we need to factor out h in this case. When you factor out h, it will be h. Then you'll be left with 2x there. So remember that h times 2x is 2xh. So to get to h squared, we need h there. To get it h, we need 1, right? So divided by h. So this and this, they will cancel. We're left with limit as h approaches 2x plus h plus 1. All right, the last step will be when we substitute. Okay, this is 1. Sorry for that. When we substitute 0 here, we'll be left with 2x plus 0, which is 2x plus 1. So that will be the solution. As I've stated when we started, that our solution will be 2x plus 1. So make sure you know how to check and make sure you know how to work with the first principle. So now we are going to work with 7.2. Yes, we are at 7.2. Determine f prime of x if f of x is equals to 2x squared minus 3x to the power 4 plus 8x. Right, using the laws of differentiation, we have to do that. So remember, let's put this into practice. We are going to say 7.2, then f of x there, which will be equal to 2x to the power of 5, 3x to the power of 4 plus 8x. Right, so from here you're going to use the differentiation rules. So the derivative. Guys, when you're here, use the power rule. You know, it's here the power rule will apply. Let's see. 2 times 5, that will be, but we need to show 2 times 5 times x. Then we subtract the power. That will be 5 minus 1. Similarly, in this case, right, so from here, it's going to be 3 times 4. Okay, times x, then subtracts the power by 1. Then in this case, it's going to be 8 with a power of invisible 1 there. 8 times 1 times x, right? We have 1 minus 1, right? So let's derive. Let's derive. Okay, we have derived there, remember? We have derived. So 2 times 5, it's 10. Then 5 minus 1, that will be 4. Therefore, 3 times 4, that will be 12. Then 4 minus 1, that will be 3. Therefore, 8 times 1, that will be 8. Okay, 1 minus 1, we are going to have 0, because x to the power of 0, it's 1. 1 times 8 is going to be 8. Guess you will end here in this case, right? So it's a short, it's very short, so that's why it's 3 marks. Let's confirm. 2 times 5, it's 10, and 5 minus 1, it's 4. 3 times 4, that will be negative 12, and 4 minus 1, that will be 3. 8 times 1, that is 8. Then 1 minus 1, it should be 0. X to the power of 0 is 1. 1 times 8 is this. So we are correct, right? So 3 marks. Then we go to 7.3, which will be our last question in this video. So the tangent to g of x is equals to x cubed plus 3x squared plus bx plus c has a minimum gradient at the point -1 and 7. For which values of x will g be concave up? They are talking about concavity. Concavity, guys, it's a point of inflection. Actually, we are going to work with point of inflection, which means it's a second. Remember that the point of inflection, it's a second derivative. But first thing first, our first statement says that the tangent to this graph has a minimum gradient. You highlight this word, has a minimum gradient. When it has a minimum gradient, it means remember the gradient of a tangent is what? It's a first derivative. The gradient of a tangent is a first derivative. So let us put this into practice so that we know what we are dealing with. So we are given g of x here, as well as ax cubed plus 3x squared. We have 3 missing values there. Okay, that means simultaneous equation may apply, might apply, it will apply, right? So they said it has a minimum gradient at point -1 and 7. So we will derive this original equation there. So what are we going to have? The first derivative of here, 1 times 3, it's 3. So we're going to have 3x squared, because 3 minus 1 is 2. 3 times 2, it's 6, and 2 minus 1, it's 1, right? We're left with 6x, and here we'll be left with b, right? Remember that 1 times b is b, and 1 minus 1 is 0. X to the power of 0, it's 1. 1 times b is b. So it passes through. Remember that it is at negative 1 and 7. So meaning that where there is g of x, we are going to put negative 7. And where there is we are going to put negative 1. So in this case here, we are going to put negative 1 plus b. Okay, so let's work. Negative 1 squared, right, that will be 3a. Okay, that will be 3a, and 6 times negative 1, that will be minus 6 plus b, which is negative 7 there. So we need to make equation 1. What we will do is to transpose it is to transpose negative 6 to the other side. It becomes positive 6. Negative 6 plus 7, that will be minus 1. So we are going to have negative 1 there, as well as 3a plus b. So we are going to transpose 3 to the other side. It becomes negative 3a, which is equals to b. Then we are going to name this equation 1. We are not done, right, guys. Remember that they said for which values of x will g be concave up. From here, you are going to derive these twice. We're supposed to derive these twice, but because we have derived once here, we will take this and derive once. There is no need for us to derive twice again. So we are going to take the one that we have derived, which is 3ax squared plus 6x plus b. So we will derive it. So we are going to say second derivative of g of x is equals to 3 times 2, that will be 6. Therefore 2 minus 1, that will be 1. So we are left with 6ax. Therefore 6 times 1, that will be 6, and 1 minus 1, that will be 0. X to the power of 0, it's 1, and 1 times 6, it's 6. So in this case, we have 6ax plus 6. So remember that the derivative of a second of this graph will be at the point of inflection will be 0, right? So in this case, you're going to place 0 there. So it passes through that coordinate, which is we are going to take the x value, which is negative 1. We're not going to take 7, so we are going to place negative 1 here. So it's going to be 6 times negative 1 plus 6, right? Okay. Therefore, 6 times negative 1, that will be negative 6 plus 6. Okay. Then what are we going to do here? All right. Okay. Let's see that we did substitute well there. Yes, that's going to be negative 1. So, okay. So in this case, what am I going to do? 6 times negative 1, that will be minus 6. That will be minus 6a, right? So now I want us to transpose that 6 to the other side. So it will be minus negative 6, which is equals to negative 6a. Then we divide both sides by negative 6. Therefore, what are we going to have? We are going to have a is equals to 1. Okay? We are going to have a is equals to 1. So let's go to the original equation then. The original, now we have, remember that now we have a as 1. So when we put 1 times x cubed, it will be x cubed plus 3x squared there. Plus we know that, what is our b? Our b, we need to find our b, guys. So we're supposed to go to equation 1, substitute a there. When we substitute a, it's going to be negative 3 times 1, which will give you negative 3 times 1 is negative 3, negative 1 minus 3, that will be minus 4. So in other words, b is minus 4. So we are going to place negative 4x plus c. Remember they said for which values of x will g be concave up. So in this manner, this graph is like this. It started the maximum because a is greater than 0, right? So we have the local maximum and we have the local minimum. So this is where the point of inflection is, right? So we need to derive these twice, right? So when we derive this twice, okay, when you derive this, remember it's f of x, so when you it's g of x, sorry for that. So when you derive it twice, let's start deriving it first. So it's going to be 3x squared minus 6x. Okay, so this there's no need for it because The derivative of a constant is 0. There was no need for you to find this. There's no need for you to find this. So the derivative of this is 0. So we said the derivative of this, that will be minus 6. And for this, it's going to be negative 4 times 1, which will be minus 4. So we are not done. Let's derive again. So actually, we need to find the x value. Okay, where the graph of this concave up. Remember, it will concave up from here. So let's see. It will just concave up. It will start here and go here. So it goes there. So it's going to be, let's see, what are we going to have? We're going to have 6x squared. Here, 6 times negative 1 is going to be minus, okay. I feel like I'm making a mistake here. Where am I making my mistake? All right, let's work this. We should go back there. All right, let's see, what are we making? Oh, I saw here it's plus, but I put minus, so it should be plus. Sorry for here. So that means the sign. So it's going to be 6x plus 6. Then remember that the second derivative is 0. So we are having 6x plus 6. Then take 6 to the other side, it becomes negative 6. So we have 6x as okay. So we need to make x the subject, divide both sides by 6. So divide both sides by 6. This cancel. How many times does 6 goes into 6? It goes once. So it's going to be negative 1. So they said that for which values of x will g be concave up? This will happen at negative 1. When x is greater than negative 1, the graph of x will concave up, starting from here, and it goes the upward. So that's how you can work with such question. Hope you find this video useful, and don't forget to comment and subscribe. Remember, in mathematics, we will never get perfect, but we can be better. We get better and better and better. Don't forget to subscribe and share this video with others, and keep learning. We wish you all the best, and we love you.